Hello, my friends. This is LeetCode 134 gas station. So there are n gas stations along a circular route where the amount of gas at the ith station is gas I. You have a car with an unlimited gas tank and a cost I of gas to travel from the I station to its next station. You begin the journey with an empty tank at one of the gas stations. So given two integer arrays, gas and cost, return the starting gas station's index if you can travel along the circuit once in a clockwise direction, otherwise -1. If there exists a solution, it's guaranteed to be unique. Okay? So this problem isn't too intuitive, so I'm going to try my best to explain it as well as illustrate it so you understand. Okay? I want to point something out before we start, right? Look at the constraints. Always do this, right? It's just good practice. Especially when you get to much harder problems like in LeetCode contests and stuff. Like this stuff is really important. You'll notice that the length of the arrays are the same, right? Meaning if there's the length of the gas array is 5, the cost one will be 5 as well, right? So we're not going to have weird edge cases in that regard, so that's good. Okay. This mumbo jumbo of words might be a little bit confusing to explain. So we're going to go to an illustration and I'll just explain it there. Okay. So it's basically, this is example 1. It's basically saying, right, so there's gas stations, right? Each gas, you can fill up a certain amount, but it also costs a certain amount to go to the next one, right? And it's basically saying, can you pick a starting point where you can go keep hopping, right? And remember, it's circular, so when you're at the last one, you have to go all the way back. Can you pick a particular index such that you can keep going, and then make it back to the starting point that you were at, right? And before we even go further, right, there is also one constraint in the problem, which is, if we can't travel in a circuit, we have to return -1. How do we know if we can't travel in a circuit? Well, the answer is really simple, right? If the total amount of gas is less than the total cost, right, then we have a problem, because if the cost of hopping to the gas stations, if this entire array, the sum of it, is bigger than the total amount of gas we have, then at some point we're going to have a problem where we can't travel, right? And so we can't really complete a circuit. So we're just going to take the sum of the cost array, right, and the sum of the gas array. And if the sum of the gas array is less than the sum of the cost, then we have a problem when we return -1. That's how we handle the edge case, okay? Right? So basically, if the cost is if the cost of the gas array is bigger than the if the sum of the cost array is bigger than the sum of the gas array, we just return -1. That's kind of how we handle our edge case before we even do any code later, okay? So I just want to point that out. Just point that edge case out. Now we can actually focus on only solving the actual problem at hand instead of that weird edge case where we return -1, okay? And so the way this problem is going to work is a little bit tricky. Like I said, I'll try and explain this as best I can. It's not that intuitive to explain or to see. The code's really simple though, so you'll kind of understand by the end, thankfully. It's not too complicated, the solution. So, again, what do we have to do here, right? Well, we have two arrays, right? A gas array and a cost array. And we have to find a particular starting point such that we can basically make a complete circuit and get back to that starting point. And then what we're returning is the index where that starting point is, right? And so we'll handle example 1 to kind of show how we're going to do this, right? So we have one gas in our car, right? Our little car, right? Right. And it costs 3 to hop, right? So this can never be our starting point because we only have one cost here, and we have one gas and the cost is 3. So our total output technically is -2. So we can never use this as our starting point. Index 0 here can never be our starting point. Well, let's look at index 1. Okay, we have 2 gas, but it also costs 4 to hop. That's not very good, right? Because our total output again is -2. So it costs more to hop over here than we have in the gas tank. Okay, what about here? Well, here again, -2, right? Okay, now here, right, 4. We have 4 in the tank, and it costs 1 to hop over, so we have 3 left over when we get here. Okay, that's good, right? We fill up 5, so we have 6, 7, 8. And it costs 2 to go here, and you can keep doing the math, but this is starting point here works out, right? And there's really 2 things I want you to keep in mind. Like I said, give me some grace. This problem is not too intuitive to explain, but I'm going to do my best here, okay, in terms of how we're going to solve this. Okay, like, there's really 2 things we need to keep in mind, right? Imagine we're going through our array with this being the starting point here, or even before that, right? Even before that. We know there must exist a solution here somewhere, right? One of these starting points has to be valid, right? How do we know that? Because we already handled our edge case where for -1, right? Meaning we already verified that the total cost, or sorry, that the total amount of gas we have available is greater than the sum of the cost, right? Because this would be, I mean, I guess I didn't actually explicitly do that, but this is example 1. You know, so you know there's a solution because you just look at it on the other page, but we'll do it here, right? So let's take the sum here. So we have 3, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. Okay, our sum of our gas is this, and here we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, right? Okay. So, that's another thing, right? When they're equal, that means there's a solution as well, okay? So technically, as long as our gas, or some of our gas is greater than or equals to the cost, it's fine, right? So I forgot to explain that. So if they're equal, that's fine as well. But there is one thing also you should keep in mind, which is that it says it's guaranteed to be unique. If there exists a solution, it's guaranteed to be unique. What does that mean? Like, imagine you have just some weird example, like 1, 1, 1, 1, 1, 1, right? Imagine these are little gas canisters here. Okay. Where is your starting point if this is a problem, right? Because technically all these could be valid starting points. Well, what this problem is telling you in the problem statement is that you'll never have a solution like this. Or you'll never have an input like this, so you don't have to worry about that, right? Because when it's telling you here, if there exists a solution, it's guaranteed to be unique. It's really just telling you that there's only going to be one starting point in the input they give you, right? Because in that example input I gave you, technically there's 3 starting points. You won't ever have that. You'll only have one starting input. Okay, and that's why I'm saying it's hard to intuitively explain or understand this problem, because there's just minute little details that you gotta keep in mind. Okay, so we know that the sum of the cost is not greater than the sum of the gas. So this is not the case. So we know that there exists one solution. Okay, so because we know there exists one solution, we know that one of these starting points has to be the index we want to return. That's number 1. Number 2 is we're starting at the start of the array and we're traversing all the way, right? So this is initially our starting point right here, right? We got a -2 overall, right? We can't hop over, right? So this is not our starting point. Then we go here, not our starting point because we got a -2. Here, not a starting point, right? When we start here, we made it to here, right? So we made it to the end of the array without any problems. So that means this has to be our starting point, right? That's what we want to return, this index right here. Why is that the case? Because again, we're going linearly through the array. So if we get to the end, right, without any issues, we know whatever our initial starting point is, and that will change over time depending if we get a negative, right? Because this won't be a starting point because it's negative, so we move over here. If we make it to the end of the array, whatever our starting point we came from, that's our solution, right? So our starting point is here. So we know that if we made it to here, this is our valid starting point. Because there's guaranteed to be one solution, right? And the ones after it, after the starting point, haven't given us any problems. So by the time we get to the end, we know that this is our starting point, right? And it won't be any of the ones before. And it won't be any of the ones after either. It won't be any of the ones before because obviously we move forward for our starting point, and it won't be any of the ones after because if it was, I mean, we would have had a negative number, and we would have moved our starting point forward, okay? So yeah, that's basically the two things you got to keep in mind, the two big things of how we're going to solve this problem. And yeah, this problem is really, it's the solution will make a lot of sense, but it's really complicated to explain. Okay, so let's do this. So we have a -2 here, right? So this is not our starting point. -2 here, not our starting point. -2 here, not our starting point. Okay, when we go here, we have a 3, right? So this is our valid, so new starting point. We're going to hop over here, right? We add 3 to the 5. We have an excess, right? Then we subtract 2, and whatever that number is will be positive. And then you can loop around and do the math if you want. But you'll see that this is our starting point. And what index is this? 0, 1, 2, index 3. And if we go to example 1, it should be 3, okay? Now let's go to example 2. I don't even know what the solution is. Or the output should be, but we're just going to do this to show you that this will work. Okay, so 2 minus 3 gives us -1. This cannot be our starting point, right? So we're going to go here. This will be our new starting point. 3 minus 4, that's negative. That cannot be our starting point. And then we'll go here. 4 minus 3, that is a 1, and we made it to the end of the array. So this is our starting point, right? We can basically, I mean, if you want, you can do the math. I'll just do it really quick because this is a very short example, right? We have an excess of 1. When we loop around, we add 2, so we have 3. 3 minus 3 is 0, right? So technically we can hop over, but we have nothing in the gas tank now. Let's add 3. We have a 3. 3 minus 4 is -1, so we cannot hop over. Oh, right. Yeah, so when we get to here, it's -1, so we actually can't come back over here, so we don't have a valid solution. But even before that, we should know we don't have a valid solution, right? Because the sum of this is 5, 6, 7, 8, 9. This is 5, 6, 7, 8, 9, 10. Right, I didn't check that, my bad. But in our code, we'll check that, right? The sum of the cost here is bigger than the sum of the gas. So we know for sure there's not even a valid solution. We didn't even technically need to check anything here. In our code, we won't even check any of this stuff because we will hit our edge case, right? So anyways, that's pretty much it conceptually and visually. So I hope it will make sense to you. The code, I swear, it's way simpler and it'll make so much more sense. But I hope my explanation and illustrations helped. Okay, now we're going to go back into the code. Okay, we're here in C++, right? Or sorry, not C++, in Python. I do these videos for both C++ and Python. But here we're in Python. Okay, so we're going to say edge case, right? Check if no solution exists, right? E.g., is our total gas available, right? Less than the gas, right? Because if our total gas available is less than the gas, we don't have a solution, right? Because how can we travel in a circuit basically if the cost to travel is greater than the sum of traveling of all the circuits, not the circuits, the gas stations, right? If the sum of the costs is great, and this should be cost, not gas, sorry. If the sum of the costs is greater than the sum of our total gas available, then we obviously can't travel in a circuit. Okay, so we're going to say if the sum of the gas is less than the sum of the costs, well, that's an issue, right? Boom. Okay. And I'll just write this here. Don't have to, but I just will, just for you to keep it in mind, which is the constraints, right? The gas, the arrays of these two things will be the same, right? So that helps us. And then there's also one unique solution, right? So basically, if there is no solution, right, we'll hit that up here. So we know that there has to be a solution. And we'll just call the result index. We're going to start at 0, okay? Okay, we're going to return. So remember, we're going to remember what I showed in that illustration. We're going to start of the array and try and make it towards the end. Okay, and we will make it towards the end. And initially our result index is going to be at the start because we're starting at the start of the array, right? So I'm going to say for I in range length of the gas, okay, right? And we're going to need a total to basically know whether the sum of the two if the cost exceeds the amount of gas we put in at any point. So we're going to say the total is going to be plus equal. And remember, we're going to take the gas that we put in the car, subtract that by the cost. By the way, the reason we need a total is because if we have like 4 in the gas and it costs 3, we have a total of 1 left over. And obviously that's still in our car. So in the next station, if we fill like 3, we need to do 1 plus 3, right? So we need a variable for that. So our total, right? If the total at any point is negative, well, we know that this cannot be our starting point. So let's set our total to 0 and move the result index. And the result index here, by the way, maybe it's kind of a bad variable name, but it's really just our starting point index, right? So the current index that we're on, right, it leads to a negative total. So our result index is going to basically shift to wherever we're at, which is the I, right? The index I, we're going to do I plus 1. Okay. And then I think that's it. Like I said, the code, explaining this intuitively with illustrations is a little harder. The code itself is very simple, as you can see, right? We'll go over this again really quickly just because I want to make sure you understand, but this is just the edge case, right? Read the problem statement as well, again, if you need to, right? Like if it helps, right? The total is just to keep track of how much we have in the car at any point, right? If at some point, basically our costs exceeds the amount of gas that we can have, then our starting point has to shift, right? And that's why we do this. We're shifting the starting point and setting the total to 0 because basically we're choosing a new starting point for our solution. And that's it, okay? So yeah, like I said, intuitively explaining this is not the easiest, but I hope this code and my illustrations helped you, and I'll see you in the next one. Peace out.